Hello and welcome to Office Hours with me, your naughty professor. You'll have to forgive the angle today. I'm working with what I've got. I know if I get a little too close, you're gonna get all the curves and none of my face. So I'll try and stay in frame, and if I don't, I'm sorry if you get a little bit distracted. Today, I am just gonna straight up geek out with you a little bit. This isn't something that you would ever need to be able to do on the spot, on a test, but it is something that's kind of good to see. I'm gonna show you a proof of the Pythagorean Theorem. We've been talking a good amount about Pythagoras. Crazy old Pythagoras believed that we should keep our urges to ourselves, and actually even believed that if you are having procreative sex, the only okay kind of sex, you should try not to be too sexy about it. He actually had rules that while you're doing it, try not to get really turned on. Try to keep it down to a low simmer, just what you need to do to come. Which I'm glad isn't a rule that I have to follow. Yes, I love Pythagoras, but there are other things I love more. So, let's get to a proof. I'm going to draw you a pretty picture, and that picture, of course, is going to have to start with a right triangle. There's a right triangle. And oh, naughty professor, you have been so naughty, drawing it all off kilter like that with the hypotenuse on top. Well, we'll work with what we've got. There's my hypotenuse, C, and my legs, B and A. There's a reason. There's a method to my madness. I didn't just draw a diagonal to mess with you. We're going to make some copies, and we're going to glue those copies on and create a whole big picture out of this. Let's see, that's about length of my arm. It's a copy, so it better have the same length hypotenuse. Oh, that's terrible. What am I doing here? That's the hypotenuse. There's my right angle. Alright. In fact, that line can extend over here to another right triangle. And oh no, put the hypotenuse in the wrong place again. Hypotenuse needs to be on the bottom. And that line, we'll put B back in a second, can extend to another right triangle. Alright. So now, putting B back as promised, we have 4 copies of this same triangle, our original, and 3 more that had better have the same length sides as the original because they're copies. So this is A, this is A, this is A. Also, this long line here is B, this line is B, and this line is B. This is C, this is C, this is C, this is C. Alright? Yeah. It's getting a little messy. We've got a lot of different things going on. So I'm going to do a color for each picture that we're actually looking at. The first thing that we'll notice is this whole big square, which is C by C. The big square is C squared. But the total is also the sum of its parts. We could also make this big square out of triangles, like we did. So let's look at each of those triangles. This one, for example. My original triangle was A by B. The formula for the area of a triangle is 1/2 base times height. So I have 1/2 B times H. This might seem a little weird because it's at a diagonal. This isn't the base though, unless this is the height. The base and the height need to be perpendicular to each other. We wouldn't say that this is the height and this is the base, even if this was the length that we had. Height is vertical, base is horizontal. Here, we've only got a horizontal, we don't have anything vertical. So what I'm just going to do is just turn it in my mind. Let's write it like this. Now I've got B, A, C, and a right angle. So this guy's area is 1/2 AB. That's the triangle. All right, so that's equal to 4 1/2 A times B. And a little extra. We've also got this tiny little piece in here. We've got 4 1/2 ABs, and then we've got an extra box. Let's get a new color for that box. This I'll draw over here is a square. Its area is going to be side length squared, or base times height. Base and height are the same in this case, so we just multiply them together. And each of these sides, I know it doesn't look like a square, bear with me. Don't tell anyone I have an art degree. Each of these sides is B minus A. Right? This whole length is side length B. This part of it, because of this triangle here, is side length A. So what's left over there is B minus A. That's the length of every side of this square. I mean, obviously, because it's a square. So the area of that baby is going to be B minus A quantity squared. A little bit of algebra here. Let's see, if I'm multiplying B minus A times B minus A, you may have heard this called foiling. Basically, it doesn't matter which order you do things in, but we need to get all the possible combinations. B is multiplied by B and negative A is multiplied by B and negative A. So we end up with B squared. A squared, that's negative A squared, which is the same as A squared. And then some what we call middle terms. B times negative A and negative A times B. Hey, that's the same thing because of the commutative property. So that's just 2 negative AB. So we've also got minus 2AB. All right, let's put this down here. Minus 2AB. Oh, read the whole thing here. Oops. All right. A squared plus B squared minus 2AB. All right, here's where the magic happens. That was equal to C squared. This, 4 times 1/2 AB, well, 4 times 1/2 is 2, so this is 2AB. Whereas this is also 2ab, but that's a negative 2ab. So that means, wonder of wonders, that cancels out that. So all we've got left over is c squared, a squared, and b squared, which is what we wanted. And remember, these aren't just random symbols that we picked out of thin air. Pythagorean theorem is not c squared equals a squared plus b squared. The Pythagorean theorem is, if you have a right triangle that's labeled like this, and you take its sides and name them a, b, c, you're going to end up with a squared plus b squared equaling c squared. So, I hope you've enjoyed a little bit of extra flavor to add on to your education. Like I said, this isn't something that your teacher's ever going to ask you to do in class. There are actually a whole bunch of other really cool proofs of the Pythagorean theorem that use similar techniques, a lot that just come from a picture. And this is one of my favorites, so I thought I'd share it with you because I just assume if I love something, you're gonna love it too. Hope I'm right. Bye.